Okay, so we have another case of side, side, side. So here I've got some kind of quadrilateral, PQRS. And let's say that as part of this, it's given that SP is congruent to QR. So that's these sides. And PQ is congruent to SR. So those are my givens. Does it make sense to then say that by side, 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 that these two triangles are congruent? Do I have 3 pairs of congruent angles between those two triangles? Triangle PQS and triangle RSQ. The givens tell me 2 of them. Can I come up with a third on my own? Oh?
Triangle PSQ is congruent to triangle QRS.
Okay, that's my goal, is to say that these two triangles are congruent. That's where I'm trying to get to with this. I do want to say that PSQ is congruent to, I want to write it down slightly different. So I said PSQ, so I want to say RQS. And now the reason I got to write it that way, let me scoop this up.
You got to start at the vertex, right?
Yeah, the P's correspond. PS and RQ are equivalent segments. So that has to be reflected here. But where's that third side?
I'm not sure about this, but SQ is congruent to PR.
I don't know. SQ looks a lot longer than. Oh wait, PR. This one over here. I'm not talking about that side. But you know, you're onto something. If I look at my list of sides I've mentioned, I've got SP. So here's SP. Here's RQ right here. Got those guys mentioned. Got PQ and SR, PQ and SR. You want to mention SQ. What would it have to be congruent to? QS. Do we have any rule that says that a segment's congruent to itself? No, reflexive property. That one I told you guys back when we memorized it 2 chapters ago. And you were like, seriously? Something equals itself? We have to write that down? We're going to need that? Ta-da! Need it. I just didn't need it for a couple of chapters. But there I've got 2 triangles. So I've got this triangle here. And I've got this triangle here. And they're congruent to each other because I can match up 1 pair, 2 pairs, 3 pairs of congruent sides between the 2 figures. I don't need to worry about any angle measurements. I just need 3 pairs of congruent sides. And I have to be a little creative about where I go looking for these congruent sides.
Wait, so how do you have 3 congruent pairs?
3 pairs? Well, these first 2 were given to me.
Yeah, I get those 2, but the third one I don't get.
This side right here is equal to itself.
Well, how's that like a pair? It's just one side.
Because it's a side on this triangle, and it's a side on that triangle. One other way to do this, a lot of times when you've got a figure that's got the 2 triangles sharing a side right there, is you can split it up. And now you can see this side and this side. They're both SQ, but they're the same SQ. And so it might make it easier to see, well, hey, if that's 10, that's got to be 10. And that's why they're flat reflexive property. The other ones I want to remind you guys of here is to watch out for words like bisector and midpoint. Those also indicate 2 things that are equal measurements. And those are going to be very useful in using side, side, side in order to show that 2 figures are congruent, 2 triangles are congruent.